Hello friends, let's start with one important topic of geotechnical engineering, that is pore pressure parameter. So here we will be talking in terms of two parameters, that is the notations are A and B. There are two pore pressure parameter. Now what do you mean by pore pressure? So basically you should know that whenever we are talking regarding effective stress, so effective stress is equal to total stress minus pore water pressure. Whenever we are talking about your consolidation, we are more focused on effective stress, or we are more concerned about effective stress. So how we are getting this effective stress? It is the difference of total stress and pore water pressure. Now pore pressure parameter, first pore pressure parameter, that is B. So B is the ratio of delta UC divided by delta sigma C. Pore water pressure or pore pressure is denoted by U. So delta UC is change in pore pressure. Okay, I can write delta UC divided by delta sigma 3 also. So this is change in pore pressure, change in pore pressure due to increase in cell pressure. I will explain you what is this, and divided by what is, see, delta UC is this one, and delta sigma 3 or delta sigma C, that is change in cell pressure, change in cell pressure. Okay, so we know what is sigma 1. Sigma 1 is major principal stress, and sigma 3 is minor principal stress. Okay, that we know. Now sigma 1 minus sigma 3, that also we know, that is sigma D, that is your deviator stress. Okay, so what is the range of B? Just note down, B is equal to 0 for dry soil. For dry soil, the value of B is equal to 1 for saturated soil. So can I write 0 less than or equal to B less than or equal to 1? So this is the range of B. We all know what is saturated soil. Saturated soil is that soil whose all the voids are filled with water. Okay, so delta UC divided by delta sigma 3, that is pore pressure parameter, which is your value B. Okay, now another pore pressure parameter is A. A is also pore pressure parameter. Okay, so when let me write, A bar is equal to A into B, both are pore pressure parameter. So what is A bar? Is equal to delta UD upon delta sigma D. D stands for deviator stress. So delta UD is basically change in pore pressure due to deviator stress. Deviator stress is sigma 1 minus sigma 3, and sigma 3 is your, what is sigma 3? Sigma 3 is your cell pressure. Basically sigma 3, that is your cell pressure. So change in pore pressure due to deviator stress, and delta sigma d, that is change in deviator stress. Deviator stress. Now delta u, that is change in pore water pressure. So that is basically we have to add delta uc plus delta ud. C means your cell pressure. Okay, change in pore water pressure. U is your pore water pressure and C is cell pressure. So delta uc plus delta ud. I am writing on another page. Let me change. So what is delta uc? Again I am writing here. Just note down. Delta u is equal to delta uc plus delta ud. Okay, so delta uc, u is pore water pressure. So that is delta u means change in pore pressure due to cell pressure, due to increase in cell pressure, due to increase or rise in cell pressure. And delta ud, that is change in pore pressure due to D is deviator stress. Okay, so finally, see, this is your basic formula. Delta u is equal to delta uc plus delta ud. So we have to sum up the difference or change in pore pressure due to cell pressure as well as due to deviator stress. And the final formula of delta u, that is change in pore water pressure, is equal to B, capital B, into bracket delta sigma 3 plus capital A delta sigma 1 minus delta sigma 3. Now here remember one more thing. If there is undrained for undrained triaxial test, on a saturated clay, Poisson's ratio, we know what is Poisson's ratio. We have studied in strength of material, denoted by mu or sometimes 1 by m. So basically it is lateral strain upon longitudinal strain, we know that. But here the formula of Poisson's ratio is equal to sigma 3 divided by sigma 1 minus sigma 3. Now we know what is sigma 3. Sigma 3 I have told you, that is minor principal stress, or basically it is cell pressure. Okay, and here this we know sigma 1 minus sigma 3, that is your deviator stress. Again I am writing this, that is sigma d. Okay, so these are the formulas for this is the formula for Poisson's ratio. Now regarding one more formula for A is equal to delta u minus delta sigma 3 divided by delta sigma 1 minus delta sigma 3. Okay, and remember one thing, for undrained test, delta sigma 3 is equal to 0. This is very important for undrained test. Okay. Now regarding the values of capital A, that also you keep in mind. Capital A is equal to 2 to 3 for saturated fine sand, and the value of capital A is equal to minus 0.5 for over consolidated clay. Okay, so these are some of the values, just you keep in your mind. Basically, A depends on, you can note down, A depends on what? Depends on, number one, it depends on strain, it depends on anisotropy, even it depends on sample disturbance, and it depends on OCR. Okay, that is over consolidation ratio. Okay, thank you very much.